Hi everyone, and welcome back to educator.com. In this mini lesson we're going to talk about horizontal kinematics and just go through page 1 of the A+ Physics worksheet, and you can find the link to that down below. Note again that these are not AP level problems, but they'll get an idea of do you have that basic fundamental understanding. So diving into question 1. We've got a 747 traveling at 70 meters per second to the north, touching down on a runway. The jet slows to rest at the rate of 2 meters per second squared. Calculate the total distance the jet travels on the runway as it is brought to rest. Well, let's start by writing down what we know. Its initial velocity is 70 meters per second north, so V initial 70 meters per second to the north, touches down on the runway, and it's going to slow to rest, so its final velocity is going to be 0. Represent its acceleration, and we need to use the scale. 1 centimeter is half a meter per second squared. So if we want 2 meters per second squared for our acceleration, our vector must be 4 centimeters long. So I would draw something that looks kind of like that, making sure that that distance is 4 centimeters. All right, number 3. An observer recorded the following data for the motion of a car undergoing constant acceleration. What's the magnitude of the acceleration of the car? So we've got this graph, this table of information, and it's giving us time and speed. Well, acceleration is change in velocity divided by time. And we could pick any of these changes in velocity we want. We could look between those 2 points. We could look between those 2 points, or between those 2 points. And because it's a constant acceleration, they should all be the same. So let's just make this simple. Let's go with that is our initial and that is our final point. So acceleration is change in velocity over time. Delta anything is the final value minus the initial value divided by the time. Our final value of speed was 7 meters per second. Our initial is 4. And the time it took to do that, well, from 3 to 5 seconds is going to be 2 seconds. So I end up with 3 meters per second over 2 seconds, which is, of course, 1.5 meters per second squared. Answer 3. Number 4 here, we have a car traveling on a straight road at 15 meters per second. So our initial velocity is 15 meters per second, and it accelerates uniformly to a speed of 21 meters per second, final velocity 21 meters per second, in a time of 12 seconds. We need to find the total distance traveled by the car in this 12-second time interval. And as I look at my kinematic equations, if I'm looking for delta x, or the distance traveled, I don't see anything that jumps out at me as a way to get it directly. So what I'm going to do here is I'm going to solve for the acceleration first. So I know that acceleration is change in velocity over time, which will be final minus initial velocity over time, or 21 meters per second, minus 15 meters per second over 12 seconds. 21 minus 15, that's 6 meters per second over 12 seconds. Therefore, I would say our acceleration is going to be 0.5 meters per second squared. I have another item that I know. Now I can use any of the kinematic equations that has my delta x in it in order to find the distance traveled by the car. I'm going to go with delta x equals v initial t plus 1/2 at squared, which is going to be, we've got 15 meters per second, our initial velocity, times our time of 12 seconds, plus 1/2 times our acceleration, 0.5 meters per second squared, times our time, 12 seconds squared. I'll put all that into my calculator. We have 15 times 12, 180, plus 1/2 times 1/2 times 12 squared, which is 144, for a total of 216 meters. Answer 3. All right, let's try one more. A race car starting from rest accelerates uniformly at 4.9 meters per second squared. What is the car's speed after it has traveled 200 meters? Well, let's start with our given. Starts from rest, v initial equals 0. Accelerates uniformly at 4.9 meters per second squared. There's our acceleration. We want to find the car's speed after it has traveled 200 meters. All right, to do this one, I would use something like v squared equals v initial squared plus 2a delta x, which implies then that v squared is equal to v0 squared. Well, that's easy. 0 squared is 0. So that's going to be equal to 2 times our acceleration, 4.9 meters per second squared, times delta x, 200 meters, which implies then that v squared equals 2 times 4.9 times 200 meters. It's 1960 meters squared per second squared. And if I take the square root of both sides, then I find that my velocity is going to be equal to about 44.3 meters per second. Correct answer, number 3. All right, that concludes page 1 of our horizontal kinematics worksheet. Thanks so much for your time, and make it a great day, everyone.